All right, let's work another example here. So we want to convert this guy to rectangular coordinates instead of being in polar coordinates, right? So we're taking something with r's and thetas, and we're writing it as something with x's and y's, right? So again, we can use these to relate x's and y's and r's and thetas. We can use these relationships. So we're just trying to kind of manufacture this sort of stuff over here. So what I would see first right off the bat is that's almost this, yeah? So I can just apply the tangent function to both sides of this equation here, right? If I've got two things that are equal, well, their function values ought to be the same also, right? So we've got tangent theta and then tangent this guy here, right? And that's a special angle, how convenient. So anyway, we got this now. So I know that that can be written y over x. That's great. And now I've got this. Well, we know what tangent 4 pi over 3 is. And if we need to draw the circle, we can draw the circle, right? 4 pi over 3. So 1, 2, 3, 4 pi over 3. So that angle is 4 pi over 3. And we know the coordinates there. Are those. So we can say tangent theta, or excuse me, tangent of that angle. Well, we've got negative root 3 over 2 over 1/2 negative. So that's just root 3. And then if we want to be extra fancy about it, we can write it like so in the standard form of this thing, which is, as we can see, it's a line, right? So that's another way we can think about this. So if we think about what we started with, theta is 4 pi over 3, then if I want to think about this, we can think about this the same way we did the last one, right? If I'm thinking about pairs, any radius that I choose, choose 1, choose 2, choose 3, choose whatever you want, -5, we can choose that one. Well, all of those thetas are, plug r equal whatever into here, and no matter what, r doesn't matter. It's always going to be that angle. So we got 4 pi over 3, 4 pi over 3, all the way down it's 4 pi over 3. And thinking about the picture, well, doesn't that make sense? For any radius, my angle is 4 pi over 3, so all my positive radii are all going to go, whoops, not that direction, excuse me, in the direction of 4 pi over 3, right? So that's this direction. So all my positive radii are going to go down here, and all my negative radii are going to come up there, right? And, lo and behold, it's a line. So what we can do with this now is I know points that are on that line, right? In particular, that guy right there and the origin. So what we can do is let me just write that. We know that -1/2 negative root 3 over 2. And, well, what's another point on the line? We could choose this one, but it'd be easier to do this one, right? 0, 0, r on the line. So we find the slope if we want to. And would you believe it? If we actually did that, the slope's going to be that. And we can see that without really doing any work, right? Anyway, we got two different ways we can do that. So we applied trigonometry to it, the problem there. And I would argue that that would be easier than doing the algebra stuff and writing the equation for the line. But it is good that we notice that, it is a line, right? That's kind of a way to check ourselves. Anyway, that's it for that example.